numbers which will occur in the 4 table. So that's what the relation says. It says that x comma y belongs to R such that it means that it will take the difference of the numbers will occur in the 4 table. That's what it means. Multiple of 4 means.
Okay.
That is what multiple of 4. Multiple of 4. That's what it means. And now if I take y minus x, what happens? I will get minus 4k, right?
Yeah.
No problem, right?
But it doesn't matter because it's
it doesn't
mod.
matter when you are taking the mod, right? So if I take mod y minus x, that is mod minus 4k, that is equal to 4k only.
Yeah.
K belongs to z plus we'll consider, no problem. So mod 4k. So y comma x also belongs to R. This means that y comma x also belongs to R.
Yeah.
So it is a symmetric relation. Done.
Oh.
Right? X comma y and y comma x. Logically, we proved that this is symmetric.
Yeah.
Right? First part is over. Now, this is the second part I did. The first part is very easy. Whether x comma y belongs to R is what we have to check. It's very easy. X comma x belongs to R. Double x. If I take x minus x is 0. 0 is a multiple of 4. Right? 0 is a multiple of 4. So job done. 0 is a multiple of 4. Job is done. So for any k belongs to z, 4 into 0 is 0.
Yeah.
So all the doublets will belong to R. So that is reflexive. It is reflexive. It is symmetric.
This is for the equivalence relation.
Yeah, equivalence relation. We are solving for the equivalence
But we
relation.
didn't do the first one.
I did the first one now. Reflexive. All the doublets belongs to R, right?
Yeah.
You can do in any order, no problem. So first x doublets belongs to R, right? X minus x belongs to 0. Reflexive. Symmetric. Done.
Okay.
Next, third thing, transitive we have to do. How to do the transitive? Consider x by z belongs to the set A. I don't know whatever is the set. So it belongs to set A. So we will consider two elements, x comma y and y comma z belongs to R.
X comma y
and y comma z belongs to R. So we'll take it. Now it says that what does the relation say? It says that x comma y will take the form 4m, let us say. Equation 1.
Okay.
And y minus z also takes the form of 4k. This is equation 2. And now we have to check, removing y, add up these two, that is x comma z, whether it belongs to R or not. This is the check we have to see. Whether x minus z is a multiple of 4 or not. Okay, ma? So add up 1 and 2. Add 1 and 2. So what will happen? X minus y plus y minus z is equal to 4m plus 4k. So that is 4 into m plus k.
Okay.
Okay. So y gets cancelled. So it is x minus z is equal to 4 into m plus k. So I can write mod x minus z is equal to 4 times m plus k.
Yeah, okay.
So it's a multiple of 4. Obviously, m plus k is some number. It is multiplied by 4 means it is occurring in the 4th table.
Okay.
Okay. So x comma z belongs to R.
Yeah.
So it is transitive.
Okay.
Reflexive relation.
Okay.
Shall we do one more time?
Yeah.
Okay, maybe you are confused. Okay, we'll see that.
No, I understood, but
we'll do. No problem. No
the
problem.
question was, can we go back to the question for 1 second?
Okay, no problem. See that. See this one. Show that each of the relation R in the set x belongs to z, 0 less than x less than or equal to 12 given by R is equal to a comma b such that a minus b is a multiple of 4.
Okay.
This we had to show that the relation is equivalence relation.
Equivalence reaction. Okay.
Yes, you have to do that.
Okay.
So for that we are solving this. So the logic,
And then
how it goes.
it's an equivalence relation.
We are showing that it's an equivalence relation. So
Because
we'll do
it's
that. Yeah, we'll do that. So how to approach? The first part is you have to show that the doublets are present within that. So the logic behind is that a minus b will be of the form 4k.
okay.
So a minus b occurs in the fourth table. That's what it means. Multiple of 4 means a minus b. The difference will occur in the fourth table.
Okay.
So we will choose the elements in that way.
Okay.
We have to choose the elements in that way such that the difference of the numbers will occur in the fourth table.
Okay.
Okay, ma? Now we'll
Yeah.
start. So let's see, the first one is the reflexive.
Yeah.
Reflexive means whether the doublets exist or not. So let us consider, let us say x comma y, x comma x, let us consider. Whether it belongs to R or not, we have to see.
Yeah.
Now, let us consider x comma x. We will take x minus x. X minus x is 0. 0 is a multiple of 4. It occurs in the fourth table.
Yeah.
So all the doublets exist in the relation R. So it is reflexive relation. Done. Tick mark. It's a reflexive. Clear?
Yeah. Yeah.
Job done. First part. Next one. Symmetric part. For the symmetry, let we will take like x comma y belongs to R.
Yeah.
Let x comma y belongs to R. And then what we had to show in the symmetry is that when you topple this, you have to show that y comma x. When you topple that also, it should belong to R. This is what we had to prove.
So it will belong because it is mod.
So because it is, whether it is not mod also, it belongs to that. That doesn't matter.
Yeah.
Because it's a negative multiple of 4. No, doesn't matter.
Yeah.
So x minus 5 will consider. So that is of the form 4k. That is equal to mod y minus x we can write.
Okay.
So that means this implies that y comma x also belongs to R. Relation R. So it is symmetric. Next part is over. The third one is transitive part. For the transitive, we have to consider two pairs. X comma y, y comma z. Like the two things we have to consider. Such that one thing is common. Such that y will be common.
Yeah.
So as for that, what I do is I will not take mod this time for the relation. We will write x comma x minus y is a multiple of 4. Let us say 4m.
Okay.
Equation 1. And now y comma z also belongs to R, right? We'll consider let x comma y and y comma z belongs to R. X minus y is equal to 4m. And y minus z is also some 4k. It is a different multiple of 4.
Yeah.
Now add up these two.
Okay.
When you add, what you get? X minus y plus y minus z is equal to 4m plus 4k.
Yeah.
Right. So y gets cancelled. So you can write x minus z is 4 times m plus k.
Yeah. Okay.
So that means that I have x comma z belongs to R.
X comma z belongs to R.
That's it, transitive.
Okay.
So this way we can do. But actually what they will say, right, in the textbook, in the solution books, how do they write is, I will tell you. How do they write in the solution books? Funda is same. But what do they do in the transitive part is, they will go with mod x minus y is equal to 4m.
Oh.
And they will write x minus y can be like plus or minus 4m. They will write y minus z is equal to 4k. One extra step they will write. Y minus z is equal to plus or minus 4k. They will write like this.
Okay.
So what do they do is, this is 1 and this is 2. And they will add these two. 1 plus 2 as usual. So when they add, you get x minus z anyway, but here you get plus or minus 4 into m plus k. Instead of 4 into m plus k, we'll write plus or minus 4 into m plus k. So this is a
Okay.
multiple of 4.
Okay.
Multiple of 4. So we'll write mod x minus z is equal to plus or minus, we can write 4 into m plus k. This is what we'll write. So it doesn't matter. It's the same. Stuff is the same. So 4 times m plus k, which is the multiple of 4. So
Okay.
it belongs, x comma z belongs to the relation R.
Okay.
Hence it is transitive. So it is a equivalence relation.
Okay.
Now the second part of the question is that suppose all are doublets. Everything is a doublet, whether it's an equivalence relation or not.
Yeah.
Yeah, it's an equivalence relation, but there is a problem with that. It's an equivalence relation. Yeah, it's an equivalence relation. Okay. Why? See, the first part, doublets exist in R.
Yeah.
Because x minus x belongs to 0 is equal to 0.
0.
That is how the form 4 into 0.
You
Fine.
are.
And now it is symmetric.
Yeah.
Because when you swap it, no change.
Same.
It is transitive also. You have x comma x minus x comma y type of thing is not there. X comma x only is there. You have another x comma x. Even if you remove in between x, you have x and x common.
X and X. Yeah.
It's the same relation which will be coming again and again. So for every element, that element itself will give the transition.
Okay. Yeah.
So it's an equivalence relation.
Yeah.
Okay, ma?
Okay.
So these are the ideas on which this question is there. Now let's move on to the next one. Now is an equivalence relation. Okay. Prove that the relation is a factor of.
Plural relation is a factor of from R to R, reflexive and transitive but not symmetric. Oh.
Prove that the relation is a factor of. Okay.
When we swap it,
No, yeah,
you
I will
cannot
tell you.
swap it.
Yeah, you cannot swap it. Factor means what? 2 is a factor of 4.
Yeah.
So let us see, like the doublets. Doublets, everything belongs to that one. So x is a factor of x. X is a factor of x. Factor of x. So that is reflexive. Fine. But symmetry will be lost. Suppose you consider 2 comma 4. You can write 2 is a factor of 4.
Yeah.
Factor of 4.
It's a
Right.
factor. Oh,
But
okay.
when you swap it, 4 is not a factor of 2.
Okay.
Factor of 2.
Yeah.
So the symmetry is
So
lost.
oh.
That's the reason. So
Like
one
3
case.
and 6 and 6 and
Yeah,
3.
yeah. Any one case, if it is lost, it is gone.
Yeah.
Disprove one case is sufficient.
Okay.
So that's how. To disprove one case is sufficient. It is not symmetric.
Yeah.
So that is how it goes. So let's see the next one. Now that it is transitive, but you see, transitive. The transitive part we are not done. So the
Oh, yeah.
transitive part is easy. I'll tell you what is how the transitive thing is. Suppose x is a factor of y. Okay, so we can write x comma y. X is a factor of y means it follows the relation like mx is equal to y. Okay, Nama.
Yeah.
See, x is a factor. 2 is a factor of 4 means 2 times 2 is 4.
Yeah.
So you get like this. Now
Yeah.
x comma y belongs to R. So like this we write. Now y is a factor of z. If I write like this, so what I can write? I can write that some ky is equal to z.
Ky is equal to z.
Right? I can write in this
Yeah.
way. Some ky is equal to z. So, but y is equal to mx, right?
Yeah, y is equal to mx.
Please put that. So k into m into x is
So
equal to z.
everything, yeah.
So x is a factor of z.
Yeah.
Factor of z. So you can say x comma z belongs to the relation R. So it is transitive.
Yeah.
So it is transitive. So this way you can say that it is transitive. It is reflexive, but it is not symmetric.
Symmetric.
It is not symmetric. Okay.
Yeah.
Right. Now let's move on to the next one. Next, if R and S are two equivalent relations on the set A, and R intersection S is also an equivalence relation. Oh.
If R and S
This is R and S are two equivalence relations on set A, then R intersection S is also an equivalence relation. This is a wow, this is really cool. Tough one to solve. Okay, but anyway, I will tell you. So we had to choose a different kinds of elements, and then we had to see some elements in common, and then we had to group them. It is something like that. R and S are is an equivalence relation. Let me verify, Amma, how exactly. I want to check whether they have done with an example or theoretically they have done this. This I will verify and let you know.
Okay.
This part alone. This fifth one, I will verify and let you know. On what basis they have gone to this one, because equivalence relation on which basis you have the doublets in this one. How do you get the common doublets? You will get the common doublets. You will get the common symmetric elements. You will get the it is like on what basis I can write, but the thing is on what basis they are expecting the answer. I want to know about this and let you know. I'll check that. Prove that the relation R on the set n cross n defined by A comma B. This is super question.
Good.
I think this one is like a super question.
6-mark question.
Yeah, super question, 6 marks question, whatever you want to call, you call it. This one is like a rumbled everyone down. NCERT. 90% students failed here to solve this. So it is like it's not that simple. So this one we have tried. Now
that relation on set.
It is the set to the relation R on the set n cross n.
Defined by
N cross n. What does this n cross n means? Oh my goodness. That means the set itself is a Cartesian product.
Okay.
Okay. This is my set A n cross n.
Okay.
On this, they have built up a relation. It is the relation between two ordered pairs, not numbers.
Okay.
It is the relation between two ordered pairs, not numbers.
Okay.
Really tough one. It is a relation between two ordered pairs. That is A plus D. When you sum these extremes, it is the sum of the means. Sum of the
Okay.
extremes is equal to sum of the means. So a plus b is equal to a plus d is equal to b plus c.
A, B, C, D belongs to n into n.
Yeah. So it's like this. A comma b, c comma d. It is like a plus d is equal to b plus c. This is the relation, and you got to prove that this is an equivalence relation.
Okay.
So this is how they have considered. So that whether the doublets, how do you write the doublet here? Here writing the doublet is not x comma x. That's what we have to understand.
Okay.
Doublet will not be of this form. Doublet will be like you have to write a comma b or a comma b.
Mm.
Here x related to x. Instead, here x is a comma b or a comma b.
Okay.
Now, where you can apply the relation
Yeah.
sum of the extremes, that is a plus b, is equal to
Okay.
sum of the means, that is b plus a. Whether
Okay.
these are equal,
Okay.
they are equal. A plus b equal
Yeah.
to b plus a.
A plus B is, yeah.
So the relation is reflexive.
Yeah. A plus B is equal to.
Now first part is done, and now second part. I will take a comma b.
Okay.
Okay, a comma b, and again I will take c comma d. These two I will take. So I will write a plus d is equal to b plus c, right?
Yeah.
Now we have this relation in hand. Now if I write c comma d or a comma b, what
Yeah.
happens now?
It is.
So
It's
extremes is equal to means. Add the extremes. If
B,
I add the extremes c plus b,
B plus B,
that is equal to means d plus a.
B plus A.
So a plus d is equal to b plus c. I got the a plus d is equal to b plus c, right?
Yeah.
I got the same condition.
So it
So it is
is
symmetric.
symmetric.
So it is symmetric. It is little bit different. Okay, clear.
Yeah.
Now the third thing, the transitive part. Now this time we have to take three order pairs. X comma y, a comma b. Okay, we'll take like a comma b, x comma y, and again c comma d. We take like this. And now we write a comma b is related to x comma y. If I had to
Okay.
write the relation, how does it look like?
A, B, A,
Add
N.
up the extremes in both the cases. A plus y,
B plus
add up the means, that is b plus x.
plus X.
So let's write this first one. And now x comma y is related to c comma d.
Yeah.
So how do we write this again?
X plus D.
X plus d is equal to y plus c. X plus d is equal to y plus c. We can write like this. Now using these two, you have to get the condition. How do you get the condition is the question mark. So it is simple only, we'll get it. So here what I do is, from the equation 1, I will substitute x is equal to a plus y minus b.
Okay. A plus
And
Y minus.
that I will put it here. X
Okay.
is equal to a plus y minus b. I will put it here. So what happens here? A plus y minus b plus d is equal to y plus c. Okay. Y is cancelled on either side. So I got the situation A minus B plus D is equal to C. So I can write A plus D is equal to B plus C. This implies A comma B is related to C comma D. So transitive. So it is transitive. A comma B is related to C comma D. Hence it is transitive. Clear, Amma?
Yeah.
So it is a equivalence relation.
Okay.
So this is how you have to prove the equivalence relation here.
Mm.
So some of the typical problems. Okay, clear?
Yeah.
Okay, right. Let us see. Oh, next one.
Classification.
Classification of functions. There are different kinds of functions are there. Let f is a function from a comma b if every element of the set B is the image of at least one of the element of set A. That is, if there are no unpaired element in set B, then we'll say the function f maps the set A onto set B. Otherwise, we say the function maps set A into set B. Okay. They said the thing is that what you have to understand one thing.
Yeah.
While writing the function, this language is the issue.
Mm.
I will tell you what is a function first of all to understand this. This language always I had the confusion even. So to derive what is exactly he wants to tell function. So it says that function it is a mapping. Okay, up to that it is fine. It is a mapping and it is a relation. Okay, function is a mapping and it is a relation. Definitely it's a relation. It relates two sets. Okay, relates two sets. That is fine. It is a mapping. It relates two sets. How it will relate? By ordered pairs.
It relates to.
Ordered pairs. So for the function, a set of ordered pairs, a set of ordered pairs following the same trend. It's like this. Function is a collection of ordered pairs which will follow the same trend. They'll follow in the usual language. I'm telling you in the very usual language. A set of ordered pairs following the same trend.
Okay.
So the ordered pairs can be infinite. The ordered pairs can be finite. It depends upon. So it is a set of ordered pairs following the same trend. What is the trend? For example, I will tell you the example.
Yeah.
Suppose I write 1, 3.
Yeah.
3, 5. 5, 7. And 7, 9. Like this, so on. I keep writing. I can write endlessly this one. 9, 11, so on, like this. So what is the trend they follow is that if I write like x, y, x and y follow one trend. Y is equal to x plus 2. Check it out. So if I mark it as x and if I mark it as y, if I add 2 for the first number, I will get the second number.
Okay.
For the x coordinate, if I add 2, I will get the second number.
3.
So
Okay.
this is called a function.
Oh, okay.
So when it is a collection of a set of ordered pairs which will follow a same trend.
Okay.
For example, another example let me take. 1, 1, 2, 4, 3, 9, 4, 16. So these follow one trend. The trend is y is equal to x square.
Square. Okay.
Right? So it satisfies that trend. All these points will follow this trend y is equal to x square.
Okay, and this is called a function.
This is called a function. Okay. Not just that. This is a part 1.
Okay.
Set of ordered pairs, that is one. Next, it maps two sets A and B. So let us say this is a set A and this is a set B. Right.
Okay.
So this is A, B, C, D. And let us say 1, 2, 3, 4. Like this is there. A maps with 1.
Yeah.
B maps with 3. C maps with 2.
Okay.
And D maps with 3. Let us say. Okay, ma.
Okay.
Like this we have A maps with 1, B maps with 2, C maps with 3,
Not
D
a
maps with.
function.
Why do you think so?
Because this thing has to have a. Oh no, it's for. Is it like that?
No, I didn't complete ultimate.
Oh.
Don't draw into
No, I
conclusion.
remember studying this. This thing has to have a. It should not be left.
I told this.
The sign.
I'll tell you what should not be left. It is the set A domain. None of the elements.
Should be left side should not be
None
left.
of the elements of the domain should be left unmapped. Shall be left unmapped. You should not leave any element of the set 1 without mapping. If you are doing it, it's not a function.
Okay.
But for the set B, it's allowed. No problem.
Yeah.
For the set B, it's okay.
Yeah. Okay.
When the first set is there, no. The first set, this confusion always arises. For the first set, you should not leave any element left unmapped.
Okay.
Most important. For the set A, you should not leave any element. You should not leave any element left unmapped.
Okay.
That's the condition for the function. For the B, you can leave it unmapped. Some element can be mapped. Some element can be left unmapped. No issues.
Okay.
Okay. Second thing is there. Thing 2.
Okay.
The first element should not repeat.
Yeah. Oh yeah.
The first element of ordered pair. That means x coordinate should not repeat. That's most important. If x coordinate is repeating, go on case. It's not a function anymore. Most important. X coordinate should not repeat. If it is repeating, it is not a function. For example, if I take like 1, 3, 2, 7,
Yeah. Okay. Got it.
5, 9, something like this, it's there. It can be a function. But if I have 1, 3, 1, 7, 1, 11, like this is coming, x coordinate is repeating, that is not a function.
Not a function.
Not a function. It's not a function. So this is the thing what you have to know. Clear, Amma?
Yeah.
Yeah. Okay. Now, these are the points, key points which you have to keep in mind. And we'll go ahead. What is the next? What next is coming? Domain, codomain, range. I think I have already discussed these things earlier.
Yeah.
Please recall that once.
Okay.
So, function this one function, on2 function. This we'll see this tomorrow. How to deal with the one function. What is a one function? What is an on2 function? Those things I will discuss tomorrow. So
Okay.
we'll close it this part already. So we'll meet
Yeah,
tomorrow.
okay.
Okay.
Yeah, okay. Bye-bye.
Bye.
Bye.
Mama.
Yeah,